Hey students, this is a good 2 mark question from topic of laminar flow from subject of fluid mechanics, and in this question it is given that velocity distribution for laminar flow as V equal to V max into 1 minus small r upon capital R square, where R is distance of any point from center line of the pipe and R is radius of the pipe and Vmax is the maximum velocity at the center. Also, as an additional data in your question, it was mentioned that Vmax is double of average velocity, and it is asked that what is momentum correction factor. Here I have highlighted this word momentum correction factor in a red line. That what it means. Momentum correction factor means that whenever we talk about velocity distribution across a pipeline, we assume that this velocity distribution is uniform or same for ideal fluid, and we take concept of averaging the velocity simply by dividing total discharge by area. But in actual case of flow, this is not true. Velocity is maximum at the center and it is minimum along the boundary lines. So as a result of which the momentum also changes along the radius, I'll say, for the pipe. So to correct this additional momentum, we use something called as momentum correction factor that basically finds out the relation between mean velocity and average velocity and momentum changes that is taking place because of that. And this assumption becomes very important if we talk about impulse momentum equations, where we assume that velocity is same across the cross section. So let's talk that how to solve such questions. Now, from definition of momentum correction, we know that momentum correction factor, that is beta, multiplied by area, that is cross sectional area, into mean velocity, its square, will be equal to actual momentum, that is V square dA. So beta comes out as integral of V square into 2 pi r dr, because if we consider the cross section of a pipe at any distance r, we can consider a thin strip of thickness say dr, and its area will be given by 2 pi r into dr, hence this will be equal to dA. So dA comes out as 2 pi r into dr into V square, its integral from 0 to capital R upon A into V mean square. So substituting value of velocity as V max upon capital R square minus small r square upon capital R square from the given relation in the question, beta reduces to V max square into capital R square minus small r square upon capital R square 2 pi r dr, and integral is varying from 0 to capital R, and in denominator we have A into V mean square, and we know that from given information that V max is equal to twice of V mean. So simply by substituting V max as twice of V mean, we just end up the integral in form of R, because capital A can be substituted as pi into capital R square. So simply by solving this simple integral within the limits of 0 to capital R, this is 0, this is capital R, value of beta, that is momentum correction factor, it comes out as 1.33. I've told you the concept and I leave upon you that how to solve this integral. It is a very simple integral, just involving quadratic terms. So students are advised to solve this integral by themselves and get the answer as 1.33. It is a numerical response type question. So answer is 1.33, acceptable within the suitable range. Thank you.